So, question 26, the last question. Phil has 20 sweets in his bag. 5 of the sweets are orange, 7 of the sweets are red, and 8 of the sweets are yellow. Phil takes 2 sweets at random from the bag. Work out the probability that the sweets will not be the same colour. So, first thing I think we need to do here is understand that he's going to pick one sweet, look at it, possibly eat it, we don't know, it doesn't say, and then without replacement pick another sweet. So we need a probability tree diagram as such. So we start here. I'm going to have to try and squeeze this in because there's not much room. So call this orange, red and yellow. So I'll use another colour here. This is orange, this is red, and this is yellow. And there's 20 sweets in the bag. So when he first picks a sweet, there is 5/20 chance is orange. It's orange. 7/20 is red, and 8/20 is yellow. Okay. Now let's say he goes to pick a second sweet. Again, he's got a choice of orange, red, and yellow. But this time, to save space, I'm just going to denote them O, R, and Y. So this is Y, this is R, this is O, this is Y, this is R, this is O, this is Y, R, and O. Okay. Okay. But this time, okay, so we assume he's taken an orange sweet on the first go. So now how many orange sweets are available? Well, there's only going to be 4, but how many total sweets are available? There's going to be 19. So he's got a 4/19 chance here. He didn't pick a sweet, a red sweet on the first go, so he has 7, and he has 8 yellow, but they're out of 19, and that's important. And again here, we have an orange sweet, but he didn't pick an orange on the first go, so we have 5/19. He picked a red on the first go, so we only have 6 left, and then he still has 8 left. And again here, he didn't pick an orange one, so we have 5/19. He didn't pick a red one, so we have 7/19. But he did pick a yellow one, so we have 7/19. So, what does this correspond to? Well, orange and orange, so we have O and O. We have orange and red here. We have orange and yellow here. We have red and orange here. We have red and red here. We have red and yellow here. We have yellow and orange. We have yellow and red, and yellow and yellow. And it asks, work out the probability that the sweets will not be the same colour. Okay, so we're looking to have where they're not the same colour. So which ones can we identify? This, 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 that, that, and that. So 1, 2, 3, 4, 5, 6. Okay, at this point I'd like to pause and illustrate from this point. There's 2 ways which you can go about it. Let me just move on to this piece of paper here because there's not enough. So the first approach is if we just calculate all these different combinations. So we can have orange and red, orange and yellow, red and orange, red and yellow, yellow and orange, yellow and red, and we work out these probabilities. Well, what is this? Orange and red, this is 5/20, times it by 7/19. Orange and yellow, this is 5/20 again, times it by 8/19. This is then 7/20, times it by 5/19, and again 7/20, times it by 8/19, and then we have 8 and 8/20 here, times it by 7 and 5 respectively over 19, and then we could add all these up. So we have the sum of all of them. So first of all, we should work out what 19 times 20 is. Well, that's 380. So they're all going to be out of 380. So 7 times 5 is 35. 5 times 8 is 40 over 380 over 380. 7 times 5 is 35 over 380. 7 times 8 is 30. Oh no, 7 times 8 is 56 over 380. 8 times 5 is 40 over 380. 8 times 7 is 56 over 380. And if we sum all these together, we get 35 plus 40 plus 35 plus 56 plus 40 plus 56 divide by 380. So this is the same as, so the probability that the sweets will not be the same color is equal with 262 over 380, which is the same as 131 divided by 190. So that's the first approach. Yeah, you're going to get the right answer, but it's probably more prone to errors just because there's so many calculations involved. Second approach is cleverly noting that the probability that, so if you, let me just move this up here. Second approach is noting probability that the sweets will not be the same color plus the probability that the sweets are the same color equals 1. So therefore, if we do 1 minus probability of 2 sweets same color equals probability 2 sweets not same color. So when are the sweets the same color? Well, this is when we have, this is going to be 1 minus, we can have orange orange, red red, or yellow yellow, which is then respectively 5 over 20 times 4 over 19 plus 7 over 20 times 6 over 19 plus 8 over 20 times 7 over 19, which is then going to give us 1 minus, so we're going to get 20 over 380 plus 42 over 380 plus 56 over 380. This will be 1 minus 20 plus 42 plus 56 over 118 over 380, which is then, plug this into your calculator, 1 minus 1 minus 118 divided by 380, and we get 131 divided by 190, our desired result. So there's 2 ways of doing it. It just depends if you notice the second way, I guess. But again, like, I can't stress, this is it's the last question on the higher tier paper. It really is quite tricky. You see how long it's taken me. Only the very, like, the A grade students and the A star grade students are going to obtain these marks. So if your target grade is like a B or a C, yeah, attempt it if you've got time, but don't worry too much.